Good afternoon, good evening, and welcome to SETI Live. And we are live and in person from the SETI Institute in downtown Mountain View, California, which is very exciting. Today I'm joined by a couple of wonderful guests and visitors, Adrienne Cool and Jessica Agnos from San Francisco State University. And they have traveled down Route 280 to join us today to talk about an amazing organization called Astronomers for Planet Earth. And we'll get more into the discussion on that organization and what it's trying to do in a moment. But don't forget, please do let us know where you're tuning in from, and I'll read out some of your names and locations. I see some of you have done that already, and that's wonderful. And please, if you do have any questions, pop those into the comments section as well, and we'll get to as many of those as we possibly can. So I think just to get going, it's called Astronomers for Planet Earth. You're a couple of astronomers, and we wanted to prove that up front. So Adrienne, tell us a little bit about what you're interested in research-wise.
Sure. So my research is on globular clusters in our galaxy, so big balls of stars that are very, very old and interesting places for a lot of different reasons, partly for their dynamics, partly as kind of tools to understand stellar evolution. And I've been studying those with students at San Francisco State for more than 20 years, mainly using space-based telescopes, so Hubble and Chandra especially.
Okay, yeah. So that's an optical and an X-ray telescope.
Exactly.
So globular clusters are big balls of ancient stars.
Yes.
And to me, they're a very visual object. Mm-hmm. They're all very nicely bright in the optical. What does Chandra show you?
Yeah, in the X-ray, they look very different. You can barely see them, but what stands out, and the reason we do that is that what stands out are things that are especially hot. And we're looking for binary stars in the globular clusters. They play an important role dynamically in how the clusters work, and whether black holes form in the middle of them, things like that, are related to binary populations. Some binaries will be accreting binaries where one star is losing material to another, and those can be seen in the X-ray. And so what the globular cluster will look like in the X-ray is just a little bit of enhancement over the background of what you'd see elsewhere. And that those enhancements are places where we then say, oh, maybe there's a binary star there. And then we use Hubble to go try to find that.
To hone in and see the detail. Yeah. Fascinating. I love globular clusters. Yeah. Jessica, what's your area of research?
Yeah, well, I'm a master's student with Dr. Charlie Sakari, and doing research in our process, rapid neutron capture process, nucleosynthesis. She's a member of the RPA, the Our Process Alliance. And my current research that I'm wrapping up and writing a thesis on is I'm looking at 3 ancient halo stars and looking at their chemical abundances using very high resolution spectra to basically look at the abundances, compare them to the solar abundances that we have, because the R process is ubiquitous everywhere we look, to help constrain the sites of the R process. I should say the main sites we did with a neutron star merger that was observed with the kilonova recently, 2017. We were able to see that is in fact a site of R process nucleosynthesis, but trying to constrain the models to match the observations and get a better understanding of how our process elements are formed.
Okay, I think that's the future SETI Live. So we're going to drag you back down Route 280 to talk about that. When you say ancient, what are we talking about ancient-wise?
Okay, so this is interesting in that we're trying to get I'm looking for thorium and uranium very specifically right now, and with the spectra that I have is very high res, and we're hoping to get really good lines. They're a little more complicated. But ballpark, I'd say 10 to 12 billion years old.
So this is not a first generation star because it has heavy elements in it.
Exactly.
Is it a second generation or?
Yeah, so this is part of galactic archaeology, right? Like piecing together how the Milky Way was formed, and it seems as though, and also I'm looking at chemodynamically tagged groups. So the kinematics of my stars they're part of this group that we assume they have the same progenitor But they also have, there's so much to say. I'm like tripping over my thoughts.
We're getting you back anyway.
Yes. But what was the question?
First or second generation?
First or second generation, probably second-ish, I should say. Yeah.
Okay.
Excellent. Sorry.
No, don't worry about that. They're just going to say we got a lot of people tuning in. Thank you very much. Wisconsin, Connecticut, Woodlands, Texas, Canada, Manchester in the UK, Peru, Minneapolis, Vancouver, Oregon, and we'll say a few more in a little bit, and Carlo in Ireland. So welcome everybody for tuning in. I suppose we better get back on the topic at hand, which is Astronomers for Planet Earth. So where did the idea come from? How did you wake up one morning and say we needed this sort of organization? What is the genesis of us? And say a little bit about what it is as well.
You bet. Well, shall I start and you can?
Yeah, sure.
So, the genesis really was, or what the immediate thing that made it happen was we were thinking, a few people at San Francisco State were thinking about what do we want to do at a conference that was being organized? And we started sharing ideas about that and thinking, we really want to do something about climate at this conference. And the idea goes back a little bit further, but that's really where it got truly started. And there were, it was actually a meeting of the Astronomical Society of the Pacific was going to be on our campus, and students were a major part of organizing that meeting. And so, yeah, it was thinking about that and thinking of the importance of climate change and what astronomy could bring to that. Is that a fair sort of statement of the?
Yeah, essentially that is exactly what ASP was coming on campus. Adrienne and I were working together and we came together having both thought of it separately, right? And I at the time was working at the California Academy of Sciences in the planetarium, and all the programming was directed around sustainability at the time, including the planetarium. And I had seen, working with the public, how useful astronomy was as a tool to discuss climate change. We talked about limited resources and what it would take to go to the moon and what it would take to go to Mars, and carefully managing resources, and then reminding people that we're on spaceship Earth. We have finite resources here as well. And to see people be able to connect the dots, and I realized that astronomy is an amazing tool to discuss sustainability and climate issues. So yeah, Adrienne and I came together and we essentially did say we must have this.
And then there were other students as well, and other faculty and an alum of San Francisco State all came together, and yeah, we put that together. And then an important thing to say is that then just a few weeks later, after we launched the website, we were contacted by another group. They're just, it was like simultaneous genesis of this idea in so many places. Another group in Europe who'd been thinking the same thing contacted us, and we joined with them. And so, yeah, we've been, working together ever since. So
it's been amazing, the sort of the almost like the domino effect, where we had the one conversation, and as we started talking to everyone, they were yes, and the group just got bigger. And
so it's something that was in the air.
It was in the air, exactly.
And a lot of people were thinking about this.
Yes, and it started, exactly. Yeah.
Because you think astronomers, well, you're sort of looking up, and
yeah, and just to say a little more from my end too, it was, thinking hard when I understood how urgent the climate crisis was. I was thinking, well, I can do things as an individual, but I'm an astronomer. Is there something I can do as an astronomer? And it was realizing, related to what Jessica was saying, realizing, astronomers have incredible reach. We teach astronomy, classes all over. I think it's like 250,000 people take astronomy just in the U.S. every year. Planetariums, it's an unusual reach, and we have a perspective that's kind of special in the context of the importance of, preserving the habitability of our planet. And so those things together made me, just speaking personally, think, these things actually are linked, and we should use that link. And then it turns out many other people were having the same idea, and some had already been doing it, and it was in the air, and then we've come together.
It really resonated with deep into the community.
And I could show a slide if you like of just just showing here kind of where we are, now. So it's grown. So we were founded in 2019. It's grown to more than 1,700 members around the world, and from more than 70 countries. And an important thing to say is that it's the astronomical community writ large, in the sense of folks who are involved in astronomy in lots of different ways, as students, as teachers, as educators, as amateurs, as professionals.
So this is not an exclusive club of professional astronomers
not
in
at all.
their high towers and their telescopes.
On the contrary,
all hands on
deck. On the contrary, and I think that's part of the power, is that there are people coming from so many different perspectives with so many different skills and connections, and that is part of what we really like about the group.
Yeah. So looking at the statistics here, 1,700 plus members. I'm a proud card carrier, although there's no cards. Members, 74 countries, 6 continents. So how easy was it to, I don't want to use the word brand, that's awful, but Astronomers for Planet Earth has been, brought into existence. You said other groups are doing similar things, and they've all come together now under this umbrella.
I think that's right. I think many people have found a way to join with others, effectively, to work together and figure out how to do this work together. The one other sort of specific group that existed was this one in Europe, and they were just beginning as we were, and so joined with us right away, and that's been really wonderful. And then from there, it's, people find us. The internet is an amazing phenomenon.
It is.
And
it is good. Well,
it happens that I'm doing the intake these days, and every day there's another person or two who finds us from somewhere around the world, which is also very encouraging for all of us, thinking about how to do it together.
Social media, I think, played a big role in the very beginning, and then word of mouth, and again, because the astronomical community, it's close knit. And because it did resonate, because it's a passion project, and when people feel passionate about something, they want to work, they want to talk about it, and so word of mouth and the internet, I would say, really helped us grow.
And one of the things you have on your website on the first page is there's no planet B. Of course, we hear all the time, let's colonize Mars. I want to be the first person to live on Mars. I personally don't want to be anywhere near Mars. Maybe say something a little bit more about, this idea. I think as humans, we are, sometimes too optimistic. We say, oh yeah, we'll just colonize the moon. We'll go to Mars. Say a little bit about these options, and whereas there is no planet B.
Yeah, and maybe while we're doing that, I'll put up a slide just of the just showing that front page that you're talking about. So I'll say a little bit, and we can both say more about this, but I think it's a really important point that we evolved on this planet, and our connection to this planet is unbelievably strong for that reason. I think it's hard to imagine just how uninhabitable other places are sometimes. At the same time, of course, it's fascinating and interesting and valuable to be thinking about those things and thinking, but at some level, one of the things I take away from what it's taking to figure out how to put just a few people on Mars is it's a lesson in, wow, that is not a solution to our problems here. It's fascinating and all of that, but just the incredible difficulty of doing that and the challenge shows that, it is not something that will solve the problem of keeping our own planet habitable.
Right. I mean, there's the basics. We need to breathe. We need to eat. We need to drink water. And both Mars and the moon are smaller than Earth. So then that's just the basics. I agree with that. It's very important to think about it. And I'm not one of those people that thinks that we shouldn't be working towards that, because the technology that we developed to sustain life on Mars or to bring life to the moon will inevitably be helpful here on Earth, right? The technology that is developed through space exploration has helped us tremendously over the years. But exactly what Adrienne said. We developed here. We are not humans anymore if we live on Mars, right? Because the pressure is different. Everything about our lives is dictated by this planet. The mass of the planet, the gravity, the pressure of the atmosphere. Our heart would be different. Talk to an astronaut after they land, just from being in the ISS, and the pain that they go through of readjusting, just being how a mile or two above the atmosphere. It's nice for the few people who will be able to go, and they get to fulfill a dream, and good on them. But it's unrealistic completely to think that an entire population of a planet can move.
So it's an exploration, which is great, and that's very, very important. Humanity is very good at exploring.
Yes.
Sometimes there are, not so good, but on the whole, I think it's an exploring species, and yet we are so, biologically linked to this world, aren't we?
Absolutely. But even if you think about our history of exploration, when new people come to a new land and they have exchanges of diseases and exchanges of bacteria and things that hadn't been introduced before, and it can decimate a population. And just moving around on the planet has been traumatic to our species to an extent. So off planet, it's just not a solution, period.
Now, there are other planets being discovered, of course. There are about 5,000 exoplanets, planets around other stars. Some of them are called Earth 2.0. They might be Venus 2.0. We could say a little bit about that. There is a problem, though, again, that these are, even as a big Star Trek fan, it only takes sort of 12 minutes to get there in an episode. But this is not an option either. But somehow very, very interesting,
Yeah, I too am a big Star Trek fan. So, and that vision of like what it would be like to travel is just so different from the reality, as much as wonderful it is as it is to think about it. And I do like to say, for example, that to get to the nearest planet using the fastest spacecraft we've ever built, which didn't have people on it, and went really fast. I think it's something like 100 miles a second or something. It would still take thousands of years to get to the very nearest star that has some planets, And so, that too, and yet that too is not a solution. But, the discovery of exoplanets is one of the most thrilling, fascinating, wonderful discoveries, of recent times, and of human, ingenuity and capability, and we learn so much, right, about our own selves, when we find planets elsewhere. Like, we had to assume for so long that the solar system was like, the other things would be like this. Well, no, it turns out it's really different. There's so many other amazing things that have been discovered. So the discoveries are fantastic. Again, it's not a solution to the climate, emergency here, but of course we learn a tremendous amount from those studies.
And I think the other thing that it can show us is gratitude, right? Like, all of these discoveries are absolutely incredible, but the fact that our solar system formed to be what it is to support us, even in all the things that we've discovered, it's not been life. All these incredible things, it's not been life, and it's definitely not been intelligent life, humans. So I think that gratitude is a good thing to bring from our explorations, is to really understand how special this place is and not take it for granted. And I think that's what's happening, right? Like, we take it for granted. We take it for granted that our day is built around our planet's orbit around a star, right? Our whole concept of time in the calendar, it's hooked to astrophysics, it's hooked to the star. And I think our space exploration helps remind people that it's cool, it's special, let's preserve it.
Yeah. Now, we're at the SETI Institute, which is all about life in the universe. And there's a Drake equation. A lot of people who are watching and tuning in know what the Drake equation is. It's an estimate for the number of intelligent communicating civilizations in our galaxy. And they're all fascinating terms for research, but the last term of the Drake equation, which is a big capital L, which is the average lifespan of a functioning civilization. In a sense, what your organization is addressing is
well, we have a sample size of 1 at the moment, so it's not good to do an experiment without a control, and we don't want to be the experiment. But that's in a sense what we're talking about, isn't it? And that's the astronomical perspective of this term, because you are, as astronomers, as scientists, looking out and almost looking back at Earth as a planetary system rather than as a home world. So a little bit about that.
Yeah, I think that's a super interesting point, Simon. And of course, I am hopeful that SETI will find what SETI has been looking for, and of course, and so that it's no longer a sample of 1, in the foreseeable future. I hope I'm around for that. But yeah, I think that this question of can we get past this? We've got a significant hump to get over here. Can we do it? Can we? Is there the will? Essentially, it's about will, right? It's not that the solutions aren't out there. They are there. We know what to do, right? It's clear what needs to happen, and the question is, can we, as a species, pull ourselves together to do the things that need doing? And it's an important question, and yeah, it's a great point that it connects to that last term. Yeah.
And I think also with I think a shift in perspective is essential to get over that hump. And again, that's what the driving force behind Astronomers for Planet Earth, or A for E. But even though we know technically that our planet orbits a star, I think most of us walk around with that sort of snow globe thing, right? We're here and that's out there, but in reality, we're out there. And exactly what you were saying, to turn our perspective to Earth helps us again realize the finite resources, and again why I think space exploration is important too. You can see how thin the atmosphere is. You can see how easy it is to alter. You can see, and if you know more about the history of the planet and how our atmosphere was altered, right? When oxygen was introduced, it killed off a lot of life on the planet. So understanding our system is critical to finding solutions so we continue to be part of it. So essentially, we're rooting for longevity. That's what we're L. That's the L we're going for.
We want that to be a large term.
Yes.
Very much so. I'm just looking at my screen now. I'm not ignoring you. We've just got a lot of people tuning in from Athens, Athens, Greece, Seattle, Brooklyn, Sao Paulo in Brazil, Oregon, Louisiana, Texas. So welcome everybody. Please do put your questions in we have one question on the kilonova. We're going to come back to that.
Okay.
That's taking a slide. That's okay. We're going to do a whole show on the kilonova.
Nice.
I think it has a fan. So I suppose one of the questions is, what do you feel you can do about it? We all feel as individuals, we can recycle, we can, cut down on fossil fuels. What do you feel that Astronomers for Planet Earth is capable of doing, or what would you like it to do?
Great question. So, and again, we can both say things about this. There's kind of two broad prongs, two broad sort of threads in the organization of what we're, feel that we can do. One is make use of the fact that so many of us are educators, either informal educators doing public outreach or formal educators in universities and colleges. And we teach a lot of astronomy in that context. We don't always necessarily bring the view back on our planet as part of that. And we feel that we should make sure to incorporate that at every opportunity. We're talking about astronomy. Let's say, oh yeah, what does that mean about what's happening right now on the Earth? Let's build that in. If we build that in, that's, as I said, 250,000 students every year take that in the U.S. alone. 100 million plus people go to planetariums around the world. Let's be doing that. Yeah. So on the education side, and of course all the public outreach. Another side, so just getting the word out. The other side is let's make our own institutions, societies, universities, institutes, all the observatories that we use and interact with and inhabit, meet the targets that the UN, Panel on Climate Change, the IPCC, has laid out. So how do we, in order to limit warming to 1.5 degrees C, which is like, extremely important. So how do we cut our carbon footprint by a factor of 2 by the end of this decade? Let's work on that, find what levers each of us as individuals have in the different institutions we occupy or the, interactions we have, and meet that target first. Yeah, so that's.
Yeah, I think gathering numbers, where, to let people know, there's always a debate with sustainability of, is it on the individual or is it on the institution? And it's like, institutions are made and run by individuals. So I think the more that we kind of spread the word and make it clear, like, we are building for a hopeful future. We're trying to be positive and say, this is what we could do, this is where we should be, as opposed to just talking about all the negativity surrounded this. But I think building a community is at least, especially for me, my background is communications, my undergrad is communications. So I think public outreach, building community, networking, bringing people across all these different areas, and realizing that this is about self-preservation, and everyone has a role, everyone has a part to play. And just uniting. Yeah.
All right, does I have a question about a comment about carbon dioxide, and a question about spectroscopy. So one thing that we're as astronomers, you're looking at other planets, exoplanets. Something that's quite interesting is getting a signature from the atmosphere of another star. First of all, are we capable yet of detecting a signature, an atmospheric composition on other exoplanets? And what would Earth look like if Earth was going around a star 10 light years away? And what would you notice that you found interesting and exciting, and B, saying, oh, that's probably not good?
So great question. I'm not an exoplanet scientist. Let me just start by that. My understanding is, so there are people who could speak to this better than I, but I can say that we're starting to get there, but there's a ways to go, right? So there's it's been possible to look at the signature of a planet's atmosphere by having looking at it when it's in front of its star, and the light from the star comes through the planet's atmosphere, and then you look for signatures of different molecules in the atmosphere of the planet that way. So JWST, James Webb Telescope, has started to do that. A little bit was done with Hubble. There's much more to do, and it's going to be a while till we actually can do that on an Earth type planet. So, but that's a major, goal. I mean, and that's being worked towards very actively, and is achievable. But there's a ways to go to get there. It's a hard problem because Earth-like planets are so small, and that's just another reminder. Oh yeah, and oxygen in the atmosphere is one important, if you, the presence of oxygen in atmosphere is a surprising thing. And so if you see that, I know that is one of the things that people, that if one sees, that's an important thing. But we're far from that, as I understand it, for exoplanets now.
And there was a question about ever seeing CFCs, chlorofluorocarbons, for
interesting,
which would be a sign of an advanced civilization, but maybe a sign of an advanced civilization that hasn't quite yet figured out,
Is that what y'all are looking for?
Sorry?
Is that what you're looking for?
That's right.
CFC?
That would be very, very interesting, given our own experience of managing to a success that we had.
Exactly. I was just going to say that. That is something that tells you that what's possible when there's will behind it. We saw hole in the ozone layer, linked it to chlorofluorocarbons. They were banned. Ozone layers closing, or the holes closing. Yay! Catastrophe averted. Guys.
So maybe as we just wrap things up, there's a sense of optimism. Talking about climate change, talking about the limited resources of this planet is a little bit depressing.
Yes.
But what you're saying, the CFCs, which you pointed out that I didn't immediately get from this question, is that we can do something about it. And people are tuning in. Hopefully, we'll be saying the same thing. What can I do? Maybe just to wrap up, examples of what people can do, and also how do everybody get involved with Astronomers for Planet Earth?
Yeah.
What is going to happen next?
Yeah. So I mean, the first thing I will say is just something everyone can do is talk about it. It's actually one of the most important things. Is it's something that's on people's minds, but often people don't talk about it because, I don't know, it's just one of those scary subjects, right?
Yeah.
And yet talking about it, finding out that, oh wait, my neighbor and my friend and my sibling actually also care about this. And then when it's something hard, and it's fair to say, this is a hard thing, that it really helps to have other people to work with on it, and to find something to do in one's own community or one's own workplace or whatever. And there are so many things to do, all of which are useful. Anyone and we invite people to join Astronomers for Planet Earth. You can go to the website a4e.org. We'll get you there. And look around, see what interests you. There's resources there. You can join. And really, I think one of the biggest powers of the group is that it is a community where people can find one another, figure out what to do, help each other figure out how to do this. Just for astronomers, I'll say it's not an obvious thing that we can go out and start talking about climate change. No, we're astronomers. We talk about black holes. We talk about exoplanets, all that cool stuff, fun stuff. We're not used to talking about climate change, so we need to help each other, and we have been. We've been doing that as part of this organization. There's a lot of resources to do that. So find your community and talk about it are the two things I would say. Yeah.
And I would say, beyond that, it's important to put pressure on our politicians, and locally. I don't think that local politics is focused on as much as it should be, but I think it's incredibly important to put pressure, because politicians aren't going to act if they don't think their constituents care about it. And so to be loud, be vocal, and to support candidates that are actually talking about it with plans, right? We need to see plans. We need to see infrastructure. We need to see that when there's new developments happening, which, we live in the Bay Area, new developments are happening all the time, everywhere. What is sustainability goals? What's going on? And making sure we have to hold the people who make decisions accountable, and having a community makes it easier to do that, and you have more people power in that case.
Yeah, and based firmly in the science, because that's what astronomers are all about.
Yes, but be hopeful too. I just said I have 3 kids. I want to see them flourish. I want grandchildren that I can play with. You know what I mean? Like I used to, when I was a kid growing up in Louisiana. Shout out Louisiana. I camped in swamps. It is not fun. I don't want to spend my golden years rummaging for food. So come on, y'all. Let's get it together.
Thank you. A moment of optimism and hope for the future and the next generation of humanity.
This is a solvable problem.
Yes.
It is.
Yep.
Adrienne, thank you. Jessica, thank you. Thank you everybody for tuning in. You can catch this show on the SETI Institute YouTube channel, along with all of the previous SETI Lives and SETI Talks. Go to SETI.org to find out what's happening at the Institute, all the different science that's going on, all the way up and down the Drake equation. And we will be seeing you all next week for another SETI Live. So thank you very much.
Thank you.
Thank you.
And thank you very much, everybody, for tuning in. Take care.